Hi, and welcome to this edition of Stats Chats. Here we're going to chat about some non-parametric statistics, including the Wilcoxon Signed Ranks or a Mann-Whitney U. When you're analyzing data, you may be wondering, when do I use these non-parametric statistical tests? Well, because sometimes our data may not be normally distributed, when that data is greater than plus or minus 2 in terms of skewness and kurtosis. We typically use that as a rule of thumb to conclude the data is not normally distributed, and then we may decide to conduct non-parametric analysis because our data doesn't meet the assumptions of normality that are required for parametric analysis. So first, let's go ahead and run the descriptive statistics on a data set. So here I have some data sets open, and we're looking at, let's see which one we're going to look at. Let's do dichotomous empathy data. All right, so here, let's go to Analyze and then Descriptive Statistics, and then we can click on Descriptives. And I've basically selected all the continuous variables, except for gender and group. I'm not gonna select post-anxiety high and low or mindfulness categories or pre-anxiety high and low because those are more categorical variables. So all the continuous variables are here. You can click on Options. And I want to make sure that skewness and kurtosis are checked under distribution because that's going to help me identify whether the data is normally distributed. And then we click Continue. And then we click OK. And SPSS will run that analysis and generate this very large table for us. And we really want to pay attention to the skewness statistic and the kurtosis statistic and see if either of those are greater than plus or minus 2 in terms of skewness and kurtosis. So going through this, we can see that pre-trait emotional intelligence well-being has kurtosis of 5 and skewness of -2. So -2.1, so it's greater than plus or minus 2 on both. So we could conclude that the pretest data for well-being is not normally distributed. So what does this mean? Well, in terms of people's emotional intelligence, right? One branch of emotional intelligence or one factor from trait-based emotional intelligence is called well-being, and that looks at things like trait happiness and self-esteem. And so this data is not normally distributed. Now, if we want to see kind of what the spread of the data looks like, then we could conduct a histogram. So there we'll go to Graphs, Legacy Dialogues, and then Histogram. So for this, we're using pre-well-being, and I want to click this box that says Display Normal Curve, because that's going to impose a normal curve over the data, so you can see what that looks like. And we click OK, and SPSS runs that data, and we can see, okay, this is for pre-test well-being. We can see these gaps. Makes sense why it's not normally distributed. We've got a bit of a negative skew with the tail extending out here more to the left. And so we know that we need to use non-parametric statistics when we're analyzing this data. Now, if I was, writing up this assignment, writing up this information, I could take this and copy it and open a new Word document. Let's see what we have here. Open up a new Word document, and then we can paste this in. Of course, if I was doing this APA style, I would add my, title page. And so I'd insert probably a page break here so that my first page can be my title page. Then I would have to, do some editing on this to make the graph fit on one page, to make it APA style. And we could even take out some of the columns, right? We just really want to make sure we're showing the one on pre trait, emotional intelligence, well-being here, right? Like this row is what we really want to highlight. And then once we know what data we're looking at, we can go back to our data set, dichotomous empathy data, dichotomous empathy data, and then we can go ahead and analyze that data. So we want to click on Analyze, go down to Non-Parametric Statistical Test. Another dialog box appears. We go to Legacy Dialogues, and then we want to go to which, depending on what you want to look at, right? Do you want to look at well-being between the treatment and control group? You're going to be looking at independent samples. Do you want to look at well-being with the pre-test and post-test? And we're going to be looking at related samples. So we can click to related samples, and then we want to select this box for the Wilcoxon test. And here I've already selected my variables, but as you can see, you scroll down to where your variables are, and let's say we want to do post well-being. I select that, click the arrow, and it moves it over, and I have pre-well-being here. We click on options, and I want to select descriptive and quartiles here, and then continue. We click OK, and then SPSS, just like that, generates this output data for us. And this is the output data for the Wilcoxon Signed Ranks Test. We want to look at the significance level down here. It's less than 0.001, so there is a statistically significant difference between pre-test well-being and post-test well-being. We have to look at the descriptive statistics to look at that. Now, because we're dealing with non-parametric statistics, we want to pay attention to median. Typically, we're paying more attention to median than mean when it's non-parametric statistics, so we can see the post-test well-being is actually lower than the pre-test well-being, which might seem pretty surprising, except that the post-test took place during week 8, which was exam week and the last week of the subterm. So it made sense that well-being or happiness may be lower when people are sleep deprived and taking final exams. So perhaps that could have been a confounding variable. And so when we report this in APA style, we want to make sure we pay attention to the z-value, the significance level. We want to report both medians. And then we also may want to look at the effect size. So when it comes to the effect size, well, let me pull up our slide on effect size. When it comes to effect size, we want to take the z-value, which is 3.83. We just are concerned with the absolute value. Don't worry about the negative sign because the z-value is both positive and negative. So we're just concerned with the absolute value. And we want to divide that by the square root of n. And because we're looking at pre and post test, it's the number of cases. So there's a total of 60. 30 plus 30 is 60. So we divide that by the square root of 60. So we divide that by square root of 60, which is 7.74, and that gives us 0.49 for our effect size. So we would say there was a statistically significant difference, the z-value of negative 3.836, p equals 0.001 from pre, median 5.9 to post, median 4.47, with an effect size of 0.49. And that is kind of a walkthrough here of running the descriptive statistics, checking skewness and kurtosis. We would say, because that the skewness and kurtosis levels are more than plus or minus 2, we would conclude that the data is non-parametric. And then we use this to determine that that well-being data that was non-parametric is what we're going to analyze. We just did an example using a Wilcoxon Signed Ranks Test. And then we discussed the APA style results. Now, what are the implications for psychologists? Well, we may say, future researchers may want to provide this empathy training for psychology and counseling students and have them take the post-test in the middle of the semester or in the beginning of the semester instead of at the end of the semester when they're taking all their other exams. That may be one implication. All right, so I hope that this was helpful for you, and may the Lord bless you on your work.